So I've just been sitting around here getting ready to go to balls this year. Here's, I don't know if you could see it, but here's the rocket for this year, all crated up and ready to go. And what better to get in the mood for balls than to set off some black powder charges and see what happens. So a while back I did some testing with charges and found that at really high altitudes, very low pressures, surgical tubing charges didn't seem to work very well. So I came up with something more of a contained charge, and it's worked real well for me at high altitudes. So I'm going to do some tests, and I'm going to look at a fairly low altitude and a real high altitude, but what I'm really interested in looking at is a sort of an intermediate altitude, somewhere around 40,000 feet, and to see how these charges perform there, because that's where a lot of guys are interested in seeing how these charges go. So what I've got here are three charges that are basically tissue paper charges. There's virtually no containment whatsoever in them, and it's just to see what happens when there's nothing that's going to contain the black powder at all. And then I have the three surgical tubing charges. The tubing that I have is pretty thin wall. These are probably not the best surgical tubing charges that have ever been made, but my previous testing showed that it really didn't matter what the wall thickness and so forth of the charges were. They didn't really do a whole heck of a lot, but at any rate, that's what I had, so that's what I'm using. And then here's the T charge, and the black powder is actually sort of contained in this area here, and then it's just held in with some tissue paper wads on the end to hold it in place. And my theory about these charges is the tube, the empty part of the tube on either side of the charge, kind of constrains the combustion gases when they form and builds some pressure, and that's what allows all the powder to burn. I've found that basically these will burn 100% of the powder in a complete vacuum. So those are the charges that we're going to try. I'm just going to do one T charge at vacuum because I know those things work, but it'll kind of set the baseline in terms of the sound of the boom that we get when we do those charges. So here's my experimental device. I've got my vacuum chamber, and this is the plug on the end of it, and the first thing that I'm going to try is one of those unconstrained charges. And then I've got the vacuum pump here, and I'm going to basically pump down the pressure to a preset point and then light the candle. So let me go ahead and get the charge lit and we'll give it a try. Okay, this first test is going to be an unconfined charge, and for this one I've gone down to about minus 10 inches of mercury, which should simulate somewhere around 10,000 feet. So first test, unconfined charge, 10,000 feet, and I'm just going to set the camera where you can hear the noise. Three, two, one. I don't know if that was audible, but it doesn't sound like very much of that charge fired. So what we're going to do is open up the chamber, and then from the 2 gram starting charge, going to pull out whatever is unburned and weigh that for each test. Okay, that unconfined charge at 10,000 feet didn't do much. So now we're going to try the surgical tubing charge at minus 10 inches or about 10,000 feet. And I would expect that this will do quite a bit better, but we'll see. Well, that sounded quite a bit better. We'll see what kind of residue that I can recover from that charge. For the unconfined charge with the tissue paper, basically it was not possible to recover anything meaningful, but hopefully it will be with surgical tubing charges. Okay, so here's what the surgical tube looks like at the end of that test at the low altitude test. It's got some burn throughs and it's split. That's pretty typical of how they look. Here's the amount of residue. It only measured about 2/10 of a gram of residue, so it looks like most everything burned. I'm just going to check and see if any of what remains here is flammable. Okay, that last surgical tubing charge, the residue, the 0.2 grams, there was a little bit of unburned powder in that one. So now I'm going to switch to the highest altitude. I've got the vacuum pumped down as far as I can here. It's pretty much pegged out at minus 30 inches. So what I've got in here now is the T charge. And based on my previous experience, this should be the loudest bang of the evening. So this one might be a little bit more fun. Going in 5, 4, 3, 2, 1. Not too loud, but it is at a vacuum and it is inside my house, so it could be worse. Let me see if I can quantify how much residue is in this one. Okay, so we did the T-charge test, and due to the stuffing, it's kind of hard to quantify the residual, so I can't really get a weight. But I can see if any of it is flammable. So this was from the high altitude test, and we'll see if anything that was recovered burns. Actually, I'm quite confident there's nothing left, but and I think that basically shows that all of the black powder burned in that test. I'll try one more try. So I don't think there's any remaining black powder from that T-charge test, which is exactly what I've seen in the past. Okay, so this will be the surgical tubing charge at high altitude. And what I've seen before in these tests is that not all of the powder burned, so we're going to see how it works here and try to calculate the fraction of it that didn't burn. Five, 4, 3, 2, 1. There's a little bit of noise on that one, so we'll open it up and see what we get back. So we just did the test with the surgical tubing at the real high altitude, and it sounded like there was a bit of a bang, but there was a lot of unburned material. On this one, I got back 1.8 out of the 2 grams that I started with, which means that for this test there was only about 10% of the powder that burned. So we'll test it and see if it's black powder or not. Let's see. See if I can do this with one hand. Okay, so let's verify that in fact some of this black powder didn't light. I think that kind of makes the point. Okay, it's time for the last test, and this is the one that I'm really interested in seeing how it works. We tried the surgical tubing charges at 10,000 feet and saw at least 90% of the powder burn, and at 100,000 plus feet, which is the high altitude, only about 10% of the powder burned. And so this time I'm going to try it at minus 25 inches, which should be somewhere around 45,000 feet or so, where a lot of guys are trying to go. So I'm going to go ahead and adjust this pressure and try to get it right on about minus 25. Looks like we're getting close. There, we'll do it right there, and we'll light the charge. In 5, 4, 3, 2, 1. Okay, we'll recover that amount, see what's left in that charge. I recovered the residue from the 45,000 foot test, and like the high altitude charge, only about 10% of the powder burned. I'm a little surprised. I wish I had another charge. I'd test something somewhere between the 10,000 and 40,000 foot level, but we'll go ahead and show that there's lots of black powder left in this charge as well. I wish that could have worked a little better. So for this round of testing, I guess I didn't learn quite as much as I would have hoped. One thing I learned, or one thing I verified, was previous test results where at 100,000 feet plus, basically a confined charge such as the T-charge that I did the demo on here, all of the powder burns. You don't have any unburned powder at all, which is why I use charges like that on flights over 100,000 feet. The surgical tubing charges were interesting. At 10,000 feet there was a little bit of unburned powder. I'd say probably 90% or so of the powder burned. But at the 45,000 foot and 100,000 foot, only about 10% of the powder burned. I suspect in actual use, where the rocket chamber is not as large as the chamber that I'm using in the testing, and things are a bit more confined, that maybe a greater percentage of that charge would burn. And I suspect, like I said at the start of all this, that the tubing I'm using probably is not particularly thick wall, and I would suspect maybe a little better results would be obtained if with a little bit heavier wall tubing. But at any rate, at 45,000 feet and above, only about 10% of the powder burned. So if you use surgical tubing charges at those altitudes, which I wouldn't really recommend, at a minimum you need to up the amount of powder that you're using relative to what you might use at low altitude. That's it for now.